Newton's second law. Pay attention, please. It's so important, and we need it frequently for this course, Newton's second law. And it's so important in classical physics. What's it about? Look at this figure. There's a flat surface here. So you have a box here as an object. And I'm going to apply a force to the right. Okay, here, this is your force, and it's applied on this block. And if you have force here, or you have non-zero net force, at that moment, your object will have an acceleration. The acceleration of this block and the applied force have the same direction. Consequently, I can show you the acceleration here in this figure. This is A. It means force will cause acceleration. In other words, force is proportional to acceleration. Therefore, this is Newton's second law. I want to write it down. If a force is applied on an object or non-zero net force is applied on this particle, it causes acceleration. The direction of the force and acceleration is the same. In other words, if you apply a force to the right, or if you apply a net force to the right, you will have an acceleration to the right. Consequently, here, force is proportional to acceleration. Imagine the mass of the block is m. Newton, discovered this law based on many experiments. He figured out that the force was proportional to acceleration. In other words, he discovered this equation, F equal to ma. Very important. And I want to talk about this equation. It is called Newton's second law. Left side, this is net force. The unit is in newtons, I told you before. A is acceleration, unit is in meter per second square, and m is mass, unit is kilograms. I want to talk about this equation. According to this equation, we can have this conclusion that if you have non-zero net force, left side, there should be an acceleration. In order to analyze the net force on your system or on your object, we need a diagram called free body diagram. And we need this diagram to apply Newton's second law. It's so important, and please listen to me carefully. The next subject is free body diagram. Free body diagram is a kind of diagram which shows you all of forces on an object. Therefore, if you have a figure which includes all of forces from your system, it is called free body diagram, and we need it to apply Newton's second law. Right now, I want to talk about different forces here, and I would like to show you how to draw the free body diagram, because we need it. We have many forces in physics, and I want to start from the simplest one, and I'll talk about every case. And you should know how to show every force on the free body diagram. Okay, let's start. Imagine right now I have a block. Before continuing, let me tell you this one. I want to talk about the weight force. You know, every object has weight force because it has mass. If you have an object, because of the mass, definitely it should have weight force because of the gravity of the Earth. Consequently, you have a force here, and it is the direction of this force, it is toward the Earth. It is toward the ground because of the gravity. I'll talk about it later, and I'll show you the equation regarding weight force. But right now, I want to talk about the free body diagram of this force here. Now, imagine there is a block here. It's on the flat surface. Okay, it has mass, m. It is always here, and there is no forces. There are no forces on this block, and according to Newton's first law, you should have equilibrium, and there is no motion for this block. Therefore, it is always here. Okay, if I want to show you the free body diagram of the weight force, okay, at first you have to separate your block from your system, like this. Separate the block, which is here. This is your block. And right now it's suspended. I mean, at the bottom, there is no flat surface. But right now, you have only this mass here. You have only this block here. But you should apply all of forces on this block. I mean, arrows. Plot all of arrows, which represent forces. Okay, what is the first item, or what is the first force here? The first one is from a weight or gravity. And you know, the ground is here. I mean, the Earth planet is here. Therefore, gravity should be downward. I mean, direction. Consequently, weight force is always downward. And you have to show this arrow here. It's called W. What is W? Stands for weight force. And you know, unit should be in newtons. What is next? Do you agree in reality it's on the flat surface? And you know it is always here. In other words, it doesn't fall. If you don't have flat surface, of course it will fall. Your block will fall because you don't have any resistance at the bottom. But right now you have a resistance. This resistance from flat surface, which is applied on the block at the bottom, and it is upward. It is opposite to weight force. That's why this block is always on this flat surface. This kind of force, which is applied by the flat surface, called reaction force. And it should be opposite to W. It's here. You can apply every force from the middle point of your object. I mean, you can plot every force from the centroid of your particle or centroid of your rigid body. Meaning that focus on the middle point. And you can concentrate all of masses to the centroid. That's why you can assume it like particle. Therefore, focus on the middle point. I mean here. In theory, you can have this kind of assumption. Okay, second force is upward from the surface on the block. It is called Fn, and Fn is your reaction force Sometimes it is called normal force. Both of them are correct. Therefore, if you have this kind of block on the flat surface, free body diagram should have two forces. The first one is W, or weight force, and the second one is F of n. And you know they will cancel each other. That's why your block is always here and you have equilibrium because it is Newton's first law, and net force is 0. I mean, W should be equal to F of N. And you don't have any motions. This is free body diagram. Okay, next case. Look at this figure. Imagine there is a block here. On the flat surface. Has mass M. There is a force applied on this block to the right, like this. I want to call it F0. F0 can be any number. For example, 100 newtons, 5,000 newtons, 10,000 newtons. It can be anything. It is F0. I want to apply this force to the right. This kind of force can be applied by my hands, or maybe it is applied by a specific machine, or maybe it is applied by interaction with other object. It is called external force. Okay, let's do it. Separate the block, because I want to focus on free body diagram. This is your block. The first one, you always have weight force, and it is downward. Let's plot it. And of course, it is W. What is next? Of course, you have surface, and you should have reaction from the surface on the block. It is upward. Add it. It is normal force. F of N. What is next? You have to plot external force on the block. And at that moment, your diagram is complete. To the right. F0. Consequently, here you have three forces. So F0 equal to F0 is external force. Thank you.